Welcome students. Today in this video we are going to study chapter 9 class 10 and the chapter name is Some Applications of Trigonometry. Trigonometry, some applications of trigonometry. Here we are going to study the usage of the T ratios that we have learnt in the previous chapters. Now trigonometry has got a wide range of application. It's widely used in astronomy, in astrophysics, in navigation, architecture, cartography, satellite systems, music, etc. Cartography is the construction of maps. Architecture, it is used in order to find the heights and the distances of the various objects. Suppose we need to find the height of the mountain or height of a tree or height of a building without actually measuring it, or the distance, the width of the rivers we need to find, or something like that. Navigation, it's used in order to locate the position of the objects with the help of longitudes and latitudes. So trigonometry has got the wide usage. Now let us study how do we use it. See, for that we need to understand few terms, basic terms: line of sight, horizontal, angle of elevation and angle of depression. These are the four basic terms that we need to understand. First, suppose this is a tower and I'm standing here on the ground and observing the top of the tower. So the observer is here on the ground and the tower is standing vertical to the ground. That is, tower is making a 90-degree angle with the ground. We are watching the top of the tower. So this horizontal ground, this is the horizontal line. This is the point of reference here. The point, observation point, is the eye of the observer that we take. So this is the eye of the observer. So if you are looking at the top of the tower, so this imaginary line, the rays, this imaginary line is called line of sight, which is drawn from the eye of the observer to the top of the tower. So when you look upon an object from your eyes to the top of the tower, this imaginary line we have drawn, and this is called line of sight. So angle of elevation is the angle between the horizontal line and the line of sight. This angle is your angle of elevation. So when we are observing something where the observer is down and you're observing something which is above the observer, the angle between the horizontal line and the line of the sight is angle of elevation. Now, if the observer is upward, suppose this is a building. We are standing on the top of a building and here this is road. So building is standing vertical to the ground, making 90-degree angle with the ground. Now we have a car parked here. Object is the car. So observer is on the top and the object is below. So you are observing a car which is parked below on the road and you are on the top of a building observing the car, watching the car. So your line of sight, your rays from your eye, this is eye of the observer. So your line of sight will be from eye of the observer to the object. So this is your line of sight. Now road is here. We will draw a horizontal line that will be parallel to the ground, passing through the observer's eye. So the angle between the horizontal and the line of sight, this angle is called angle of depression. This is angle of depression. So angle of depression or angle of elevation, children, remember, these are always between the line of sight and the horizontal. If the observer is below and the object that is viewed is above, then the angle is angle of elevation. When you're looking up, right? When you're looking at an elevated object, when you're looking up, that's angle of elevation. And if you are above, the observer is on the top, is above, and the object that is viewed is below, then you're looking down, that is angle of elevation. Angle of elevation is the angle between the horizontal and the line of sight, when the object viewed is below and the observer is above. Angle of elevation is the angle between the line of sight and the horizontal when the observer is below and the object that is viewed is on the top. Let us do some problems and you will understand it more thoroughly. First, this example, I am taking the example from your NCERT book only. He says a tower stands vertically on the ground from a point on the ground which is 15 meters away from the foot of a tower. See, let's say AB is the tower. So this is my tower, AB. Standing vertically to the ground, that means making 90 degrees with the ground. So this is my ground. Now he says from a point, let's say this point P, which is 15 meters up. This is 15 meters away from the foot of the tower. B is the foot of the tower. The point is 15 meters away from here. The angle of elevation. So angle of elevation is angle between the horizontal and the line of sight goes here. This will be your line of sight because this is the eye of the observer and this is the top. You're observing the top. So this angle of elevation is 60 degrees. Find the height of the tower. We need to find the height of the tower. Now, how do we find the height of a tower? See, AB is the tower. It's important to describe the figure in trigonometry. The basic concept in the trigonometry when you're attempting the questions is you need to do the thoughtful reading of the question because you need to draw the figures. So follow the instructions given in the questions and draw the correct figure, first step. After drawing the correct figure, you need to describe your figure also because there are marks for the figure and the description of figure. AB is the tower. Then we have P is the point of observation. Then BP is 15 meter and angle of elevation, angle APB is 60 degrees. This is given to us. Now, in triangle ABP, how do we solve this problem? Angle B is 90. So that means I can apply Pythagoras in this triangle, right? Also, angle B is 90. This is a sufficient condition for the T ratios to be applied because how do we apply? Where do we apply T ratios? We apply it in the right triangle. So I can apply T ratios also. Now, what do we need to find out? I need to find out AB. And what is AB? If I apply T ratio, this is perpendicular, this is hypotenuse, and this is base. Remember the side which contains 90 degree and the angle is the base. So this side is base. So I need to find out the height of the tower, that is perpendicular. And what do you have? We have base. So I need to find a T ratio which need to look for a T ratio which gives me a relationship between perpendicular and base. And which is the T ratio? Tangent. Good. Tangent theta is perpendicular by base. So we know tangent theta is perpendicular by base. So here tangent 60 will be AB by 15. Base is 15 here. What is the value of tangent 60? It's root 3. So AB by 15. So I get 15 root 3 is my AP. So height of tower is 15 root 3 meters. If the value of root 3 given, you substitute and calculate, otherwise you leave it in this form only. So this is how we attempt a problem. That's simple. So basically you should be knowing the T ratios, the value of the T ratios and the ratios, these angles that we will be dealing in 30, 60 and 45. So only these three. So you should remember the three specific values. Second example, an electrician has to repair an electric fault. Electrician has to repair an electric fault on a pole of height 5 meter. So this is electric pole, AD electric pole, 5 meter high. So this is 5 and obviously it will make 90-degree angle with the ground. She needs to reach a point 1.3 meter below. So this distance is 1.3. Suppose this is the point B, 1.3 meter below the top of the pole. A is the top of the pole. So 1.3 meter below, यहाँ पे the electrician has to repair a point here to undertake the repair work. What should be the length of the ladder? This is the ladder, BC ladder. What should be the length of the ladder that she should use? We need to find BC, which when inclined at an angle of 60 degree to the horizontal. So this is horizontal. Ladder is making an angle of 60 degree with the horizontal. Would enable her to reach the required position. So this length of the ladder we need to find out. Also, how far from the foot of the pole she should place the foot of the ladder. That means we need to find out the distance DC also. I need to find out DC and I need to find out BC. This is my question. Okay. This is angle of elevation 60 degree. Now in triangle BDC, we have angle D90. Okay. Now what was given? AD was, our AD is equal to 5 meter. And what is AD? AB plus BD is 5. AB is 1.3. BD is plus BD is 5. So I get BD as 5 minus 1.3. What it will be? 3.7 meter. So this is my 3.7 BD. Now in triangle BDC, my angle D is 90. I need to find this hypotenuse. Okay, we have perpendicular, we need to find out hypotenuse because this side is my base, this is my perpendicular and this is my hypotenuse. So which T ratio enables us to find a distance, find a relation between perpendicular and hypotenuse? We know sine theta is P by H. So I'll apply the T ratio sign. So I have sine 60 degree is equal to BD by BC, perpendicular by hypotenuse. Now what is the value of sine 60? Any idea, children, what is sine 60? Sine 60 is root 3 by 2. And what is BD here? We have found out 3.7 and BC we need to find out. So let us simplify. I get BC as 3.7 into 2 by root 3, which is how much? 7.4 by root 3. But we never ever leave the answer in the irrational form. We always leave the answer in the rule of maths is always write the answer with the denominator rational and answer should be in the standard form. यही होता है rule of maths. Okay. So we need to first find out the rationalize this denominator. So if I rationalize it, I'll get this. So 7.4 root 3 by 3. Now value of root 3 is given to us, so I'll substitute that value also. 7.4 into 1.73 by 3. So if we calculate this, 7.4 into 1.73 by 3, we will get it something like 4.28 meter approximately. So I'll get 4.28 meter approximately. And what is this? Length of ladder should be 4.28 meter approximately. Answer statement is very important in the word problem, so we'll be writing the answer statement. We need to find something else also in this question. What else we need to find out? What else do we need to find out? He says how far from the foot of the pole, this is the foot of the pole, the foot of the ladder should be placed. So I need to find out the distance DC also. How do we find out the distance DC? In order to find the distance DC, we will apply DC is base. I have perpendicular, I have base, I have hypotenuse with me. We need to find out base. So either you apply the T ratio tangent or you can apply something else. I'm going to apply tangent. In triangle BDC, angle D is 90. So I have tangent 60 degree is equal to BD by DC. Tangent 60 is root 3. BD we have just now calculated, it is 4. BD is 3.7 and DC we need to find out. So I get DC as 3.7 by root 3. Again we'll rationalize it. So we get DC as 3.7 root 3 by 3. So substitute the value of root 3 and calculate. When we substitute the value and calculate, we get DC as 2.14 meter. Therefore, distance between foot of the ladder and foot of pole should be approximately 2.14 meter. So this is how you write. Very important in Trigo to write the in applications of Trigo, these word problems, to write the answer statement. Right? I hope you understood, and the rest we will continue afterwards in the other video.